Hello everyone, my name is Akshita and this is the second video in Team 542's FTC CAD series. In this video, I'm going to be teaching you guys about some of the other tools in SOLIDWORKS that you can use when you're CADing, as well as tolerancing. So we're going to start off by learning about construction lines, otherwise known as center lines. So you can get a center line by going to the line option up here, clicking the drop-down menu and clicking on center line. And center lines they behave in the same way as normal lines, in the sense that they have sketch relations and you can set measurements to them in all the same ways that you would do for a normal line, and they can be defined versus undefined, underdefined. But the only difference, or the main difference I should say, between normal lines and center lines is that center lines are not used to actually make sketches, they're used to help create references for your sketches, or guides as you're making sketches, or help you visualize as you're making sketches. And the most important, and in my opinion the most helpful thing about center lines is you can consider them as lines that don't count when you're trying to use features. And I'll show you exactly what that means. So say I have the circle here and I want to create some kind of cut here. Usually how you would do that is you would use a line and you would just make some kind of cut like that. And when I go to my boss extrude and I try to extrude from the sketch, I'll have two separate regions that I can choose from. And you can see that I can either choose this region over here, or I can choose this region over here, or I can choose both regions together. But if I were to do the same thing, and I did it with center lines instead of normal lines, it wouldn't show up in the feature. So I'm going to make the same exact thing. I'm going to exit, go to my features tab, try to do a boss extrude, and you can see there's only an option for this one sketch region. I cannot select this inner triangle shaped pie slice of a sketch region because center lines do not create sketch regions. They're just there to help you visualize. And it's not just lines that you can do this with. You can do this with pretty much any entity. So for example, if I wanted to make this circle become, I guess you could call it a center line, I would right click it and click this button. It's called construction geometry, and there's two lines here with arrows, and it would become center line. And you can see when I try to do an extrude, it doesn't work. I can't click anything because this is all center lines or construction lines. And if I wanted to switch back from a construction line to a solid normal line, I can just right click, press the same button, and it goes back to completely normal. And just to make sure you guys really understand where construction lines would be used when you're CADing for FTC, I have an example for you right here. So this is an example of sort of one compartment of the wheels on your drivetrain. And you guys will learn all about drivetrains and that fun stuff later, but for now all you need to know is that this piece over here is one panel, and this piece, the black one over here, is another panel, and the wheel sits in between those two panels and it's connected to a motor. The wheel itself isn't connected directly to a motor. There's another piece that's mounted onto the wheel with screws, and the motor gets clamped into that. And I'm going to make this transparent so it's a bit easier to see, but you can see how the motor goes into that part, and there's screw holes on this part that would screw into the wheel. So the part that we're going to be looking at for construction lines is this wooden side panel over here. And you can see that when we're making this, there's a bunch of different things we have to consider. We have to consider where the wheel is going to be, so we know where to put this hole over here, whether or not the wheel is going to be coming off of the side panel in this direction, how far down is going to be coming off the side panel in this direction, and we have to make sure that anything we put around the wheel also doesn't hit the wheel. So if we're putting screws in these holes and putting beams here, we have to make sure that these beams are not hitting the wheels. And I'm going to open up this inner panel sketch and show you guys how I've used center lines there. So you can see that when I was making this side panel, I used a center line to show the wheel. And that allowed me to experiment and look at what the panel might look like after doing the feature without having to select like these areas around the wheel. Because if this was not a center line, then this would happen. You can see how it's taking a while and there'd be all these different errors. And that's because if it, as I mentioned, if it wasn't a center line, I would have to go back and select every single area around it when I was making the feature with the sketch regions. And you can see I use center lines in a bunch of other different places, and that's mainly for alignment and references to make sure that I'm doing things correctly, to test things out, and all of that. And all of that is really, really important when you're CADing something in FTC. The next tool that we're going to learn about is the mirror tool. And the mirror tool can work with both entities and features. So when you're using the mirror tool with entities, you use it mainly to save you time. And when you're CADing parts or CADing parts for practice or just for FTC, you're going to be using the mirror tool a lot. So imagine I wanted to replicate this entire sketch with the dimensions and everything defined, but 10 millimeters away from this edge. So maybe the first thing you might think of is, okay, I'm going to use a center line, and then I'm going to define this line to be 10 millimeters long, and then I'm going to create a line over here, and then I'm going to create the circle and apply all the relations so that the dimensions are equal and all of that. But there's a much easier way to do this that requires less than half of the effort that all of this would take, and that's using the mirror tool. So the way you use a mirror tool is you first need to sketch a line from which you're going to mirror across. So if I wanted this to be replicated 10 millimeters away, I would make my line 5 millimeters away. And that would be because everything to the left of this line is going to get mirrored across, including this space. So I'm going to define this to be 5 millimeters. And I don't need to find this line because that's just a line that I'm mirroring over. And I'm going to go over here, click Mirror Entities, and I'm going to click all the entities that I want to be mirrored across the line. And I'm going to click Mirror About, the line that I want to mirror about, and there we go. We have it exactly mirrored, and it's all fully defined, and it was very much easier than the first method that I showed. And just to show you guys that it is 10 centimeters, there you go. It's exactly 10 centimeters. You can also use the mirror tool with different features. So say that I didn't want to edit my sketch, but I wanted to mirror this and make it go to this side or this side, I can totally do that. So when I'm in the Features tab, I can go and click Mirror, and for the mirror face or plane, you can click any side of the 3D object that you already have. So if I click this side, and then I click Features to Mirror, I go over here and click Boss Extrude, it's going to mirror it like that exactly. And mirror is not only applicable to mirroring horizontally, you can also mirror things diagonally, you can mirror things vertically. As long as you have a line to mirror across, you can mirror. Next, we're going to learn about the Fillet and Chamfer tools. The best way to understand what they do is mainly by just seeing what they do, and you can access them in the command manager over here. So if I go over here and I click it, I get the option to do a fillet, and fillet lets me select any edge and make it into a curve. And you can edit the size of that curve too, or the radius of that curve. You can see over here, right now it's 3, I can change it to 10 if I wanted to, and it'll be super curved like that. And what happens when you try to select two edges that'll interfere with each other? Well, it simply does this, and it gets all wonky. It doesn't let you select faces, and if you do try, then it gives you an error, because faces cannot be filleted or chamfered, because then that wouldn't make sense. And you can even do edges like these to make them filleted like that. It's loading, and yeah, there you go. And you can see that it comes up as a feature over here. And chamfer is the same thing, but instead of a curve, it adds sort of another face. So if I click on fillet and I click the drop down menu, I'll get an option for chamfer. And I can select an edge over here, and as you can see, it adds another face to the edge, and similar to the fillet option, I can change the amount that it gets cut off. And there's also multiple other settings in the Fillet and Chamfer tools, so feel free to play around with those if you wanted to explore. So the Fillet and Chamfer tools are really, really important for understanding and knowing an FTC because they can drastically change how strong your actual part that you 3D print is. So for example, I'm going to delete these. If you look at these two pieces, they're both the exact same. But if I added a fillet or chamfer here, say I made it 15, this part, this L piece with the fillet is going to be much stronger than the one without a fillet. And the reason that is because if I held this side of this L piece and this side of this L piece with two different hands and try to snap it apart, it would break really easily because this edge is super sharp. But if I tried to do the same thing with this one, it wouldn't be as easy because this edge is curved. And you can think of it as sort of fusing these two faces together when you add a fillet here. And it can either be a fillet or a chamfer, it doesn't really matter. It still makes the part stronger when it gets 3D printed. Last but certainly not least, I'm going to talk about tolerancing. Tolerancing, similar to filleting and chamfering, is one of the most important things to remember whenever you make any part that's going to get 3D printed. And the reason that is because when you 3D print something, it shrinks a little bit. It's not exactly the same measurements as you made in your CAD. So for example, if I decided to 3D print this part, and I'm going to show you guys, but if I decide to 3D print this part, the holes here that are currently 4 millimeters in diameter would instead be around 3.5 millimeters in diameter if they were actually printed. And how much that varies depends on the type of printer that you have. So for example, if you have a really, really good printer, like something like a Bamboo Lab, then it might only differ by 0.5 of a millimeter. But if you have something like an FL Sun or a Creality 3D printer, then it might differ by 1 to 2 millimeters or more. The only way to really know exactly how much to tolerance by is by getting used to the printer that you're using and 3D printing parts a lot over and over and over again. Usually the sweet spot is around 0.02 inches, which is pretty much 0.5 of a millimeter. That's what I use, and we use a Bamboo 3D printer. So just keep in mind that when you're CADing something and you have something like holes, or you have a hole that you're going to put a screw in or a hole that you're going to put a servo in, make sure you tolerance that. So make it 0.5 of a millimeter, a bit bigger than what it should actually be. But that doesn't mean you should change the distance between holes. So, for example, you can see that the distance between this hole and this hole is 111.38 millimeters. When you change the diameter of this hole, it should not change the distance between the centers of the holes, because then that's going to mess up your spacing when you try to assemble something. And you can see here I changed the diameter and the distance between the centers still stayed the same. So you need to make sure to CAD it in a way that the distance between the holes and the spacing isn't affected by your tolerancing. And that's super duper important. Understanding tolerancing is kind of the first step where you're bridging actual CAD and FTC with assembly, because you're considering how your CAD is going to affect how you assemble something. And I'm going to show you guys an example of that. So right now, imagine that you're trying to put this screw through a hole in the plate. And the diameter of the screw over here is 4 millimeters, and right now the hole on the plate is also 4 millimeters. Even though the screw fits through the hole properly in our CAD, when we actually print this part, the hole is going to end up being around 3.5 millimeters due to it shrinking in the 3D printing process. So if we went here and we simulated that by kind of just changing the hole diameter to be 3.5 instead of 4, we can see how that affects our screw. So we're going to go back here, click yes, and we can see that our screw doesn't fit through the hole properly. So if we had the plate with the hole of exactly 4 millimeters, when it actually gets printed, the screw wouldn't be able to go through all the way. And that would cause issues with assembling whatever you're trying to assemble with the plate. So instead of keeping it at 4, imagine that we changed it to 5 in the CAD. So we're tolerancing by 1 millimeter. Imagine we tolerance by 1 millimeter and this ended up getting printed. In the actual print, the hole would be around 4.5 millimeters. So we can go back here and see that in our CAD, our screw definitely fits through and there's a lot of wiggle room, but that'll decrease a lot when it's actually printed due to it shrinking during printing. And you need to make sure that you don't tolerance by way too much, because if you do that, then the part won't be able to do its function. So for example, if I tolerance this by 3 millimeters and I made it 7, then it starts to get a little bit wonky for 2 reasons. One is because you have the head of the screw almost going through the hole, and 2, now these holes are super duper close to each other, and that increases the chances of the snapping and this just becoming one big hole instead of 2 separate holes. And you wouldn't be able to change that because you don't want to change the spacing, you just want to change the size of the hole and tolerance the hole. So usually the sweet spot is 0.5 to 1 millimeters, and you'll get used to doing that more as you make more parts and print them with the 3D printer. So that is the end of this CAD video. I hope you guys learned something new, and I highly encourage you to do many practice parts and search up videos on tolerancing and all the different ways to use Fillet and Chamfer and all of that, and see you in the next video.